Hello guys and welcome. I hope that you're doing well. My name is UGD King, or I play 4K, aka I play 8K, aka I play 16K, and during this video I'm going to demonstrate Unigine Heaven Benchmark version 4.0 in 16K video resolution. This is going to be the world's first Unigine Heaven benchmark running in 16K video resolution. Today I'm running it on a single Titan RTX video card equipped with 24GB of video RAM, the first video card that allows us to run Unigine Heaven benchmark in 16K video resolution, and Intel Core i9-9900K overclock at 5.3 GHz. Before we're going to jump into the benchmark, let me real quick go ahead and demonstrate for you that my desktop resolution is set to 16K video resolution as well, real quick. As you can see, I'm using the Windows magnifier zoom tool a lot. It's going to be so handy if you're playing games or if you're using your desktop above 8K video resolution. This video is not going to be as fast as possible. This video is going to be as informative as possible in about over 1 hour. So go ahead and grab yourself your favorite drink. The best drink will be water with a lemon or tea with a lemon. Today I'm sipping the hot chocolate, Swiss hot chocolate, with premix a little bit of the coffee, but do not drink a lot of coffee. A lot of coffee is very bad for your health. So as you can see, 15,360 pixels by 8,640 pixels, which is 132.7 megapixels rendered in real time, and very crucial to make sure that your desktop scale at 100% as well, the resolution scale at 100%. It doesn't reflect in a lot of games, but sometimes it does, especially when the game developers using the font API, rendering font API as the main game engine rendering pipeline, such as John Carmack did that back with the Doom and first Quake, but newer games and newer game engines not using that. But just in case, keep in mind that throughout this video we're going to talk a lot about computer science, PC hardware. So if you are a software developer, game developer, gamer, PC hardware enthusiast, PC overclocker, graphics designer, 3D artist, it's going to be a great video for you to watch. A lot of information will be shared with you. You're going to learn a lot about NVIDIA AMD GPUs, about Intel AMD CPUs, and about the hardware, about the game development. It's just going to be a absolutely amazing video, guys. Alright, so 132.7 megapixels rendered in real time. Before we're going to jump into the benchmark, let me show you what kind of presets we're going to run today. So pretty much today we're going to compare DirectX 9 and DirectX 11 API as well at the same time, while providing multiple values, and a lot of information will be shared with you. But we're gonna do the low preset, ultra preset, low preset with the moderate tessellation, low preset with extreme tessellation, high preset with extreme tessellation, ultra preset with extreme tessellation, ultra preset, extreme tessellation, 2 times anti-aliasing, low preset, 2 times anti-aliasing, without any extreme tessellation, with extreme tessellation, then ultra preset, extreme tessellation, 4 times anti-aliasing, and low preset, extreme tessellation, 4 times anti-aliasing. So pretty much we're gonna do a lot of tests. This video will be over 1 hour. It's going to be a great value, guys, no matter what kind of industry you are in, and absolutely amazing video. Alright, I'm recording in real time. This is going to be a single take. I'm not going to edit this video, but it's going to be the best way to provide value for you. So let me real quick go ahead and introduce you to my system. So as you can see, I did this test without NVIDIA Shadowplay recording. So it was without NVIDIA Shadowplay recording, keep that in mind. So I'm running Intel Core i9-9900K. It's overclocked to 5.3 GHz or 5300 MHz, an external maximum frequency, and 5200 MHz 5.2 gigahertz on AVX2 instruction frequency, only 6 cores, 6 threads to keep it stable. I disabled 2 physical cores, disabled the hyper-threading technology in the BIOS, which is additional 8 logical cores. This is the motherboard I'm running today, Z390 ASUS Maximus here. I'm using pretty much the fastest possible DDR4, which is 1600 MHz times 2, 3200 MHz external frequency, but it's not CL16, not CL14, not even CL12. This is CL11 when T command. The low value is better. I'm using total 32 gigabytes of system RAM, DDR4 4 sticks, 8 gigabytes, the best possible scenario for dual channel, 128-bit. So no matter what kind of sticks you're running, single bank, dual bank, you're gonna be Gucci. My CPU cache frequency is set at 48 multiplier, which is 4800 megahertz or 4.8 gigahertz. The DDR4 that I'm running today, Corsair 5000 megahertz, 2500 megahertz times 2, 5000 megahertz on the output. Frequency CL18, but unstable due to that Micron technology, so Corsair cheated. But the fastest possible, one of the fastest possible DDR4, G-Skill was the fastest, I believe. But anyways, and I utilize this Micron chip as the best as possible. 3200 megahertz because it's unstable after 3800 megahertz, but CL11 1T command. If you want to keep it 5000 megahertz and above DDR4, most likely you want to run Samsung B chips. Okay, so this is the Titan RTX under CPU Z. Let me real quick go with you over it. And 6 cores scored at 5.7 times as multi-thread ratio. This is a great pretty much result for the Intel 9000 series CPUs. But when we're talking PC gaming, when we're talking gaming benchmarks, you're gonna pay your attention on single thread performance. Single thread performance 636 today. Multi-thread performance is 3628, as you can see. Let me go real quick over the CPUs. Go ahead and press the pause button. So this is much newer CPU, AMD 5950X. As you can see, I'm as fast as that CPU. This is the same AMD CPU from the years that 2018 when the i9-9900K was released. As you can see, I'm faster by that CPU by 100 points. As again, multi-thread performance, you're gonna talk when you're talking like 3D rendering, video encoding, when every single thread, every single core is utilized. This is where you're gonna take advantage. Otherwise, you're gonna take advantage through a single thread performance such as PC gaming in 2023 and older games. Go ahead and smash that pause button, but I'm gonna go through the CPU. So look at this, 12900K CPU, only by 10% faster than my CPU. So you're gonna receive 10% faster in terms of the FPS. I'm much faster than 10900K CPU, which is newer CPU, as you can see. Real quick, just go through the CPUs. This is the same CPU, but with the graphics on board. As you can see, I'm dominating by 100%, by 100 points in terms of the single thread performance. If I'm going to enable back my 2 physical cores to hyper-threading technology, I'm going to be like 5500 score on the multi-thread performance. But it's going to be unstable at 5.3 gigahertz. So to be able to keep 5.3 gigahertz stable, you gotta disable 2 physical cores and disable the hyper-threading technology. So it's gonna consume less energy, generate less heat, and it's going to be stable. Okay. As again, this is the tests that was taken without NVIDIA Shadow Play recording. So pretty much when Titan RTX is stock, it's running a little bit slower than RTX 3080 video card. Ampere GPU architecture by NVIDIA. Due that it's going to use much faster video RAM. So my bandwidth will be on the RTX 3080 will be 770 gigabytes per second. So 100 gigabytes per second less that you can see right now. But when I'm going to overclock the Titan RTX, I'm going to be a hair faster than RTX 3080 video card. Let me real quick and demonstrate it for you. As you can see, my value improved dramatically, and my bandwidth in terms of the video RAM for the GDDR6 by Samsung is 20 gigabytes per second faster than RTX 3080 video card. The difference on RTX 3080 video card will be that RTX 3080 video card is only 10 gigabyte of video RAM, which is 10,000 megabytes of the memory, video memory size, while Titan RTX having 24,576 megabytes of video RAM, or 24 gigabytes of video RAM. Keep in mind that I'm going to release a video tutorial how to overclock the Turing GPU architecture, such as RTX 2080 Ti video card or Titan RTX video card, will be available over the uhdking.com. Alright, so let's go ahead and keep moving, guys. So we're going to go ahead and start with the first test, DirectX 9, and anti-aliasing will be off. The presets will be low, so minimum possible preset. Let's go ahead and keep moving. Let me zoom out and fix this window right here. Look how small my mouse cursor under this 16K video resolution. This is just unbelievable. So what I'm gonna do, I'm just gonna move the benchmark here, and I put at the right top corner for you all the details that you can see, even the 6-core CPU utilization. The value at the left top corner will be self-explanatory and verified, and exactly value that you need. Let me zoom in. Look how small this menu right here. So I'm gonna start the benchmark. Okay, so it's benchmarking right now. So we're gonna compare DirectX 9 versus DirectX 11 APIs by Microsoft. Unfortunately, OpenGL API is not functional under the Unigine Heaven Benchmark version 4.0 if we're going to set above 8K video resolution. As you can see, the 16K video resolution is not 16K UHD due that it's was not predicted by the benchmark developers. You always, when you're developing games or software, always want to think in the future. It's only capable on the full screen to 8K video resolution, and after 8K video resolution, I believe the DirectX API is pretty much scaling by itself, and scaling as a square, as you can see, not as kind of white resolution, but as square resolution. And I believe it's using first as a height resolution as first, which is 16K video resolution, but width will be 10,000 pixels exactly. Okay. Look at this, 30 FPS. This is including NVIDIA Shadowplay recording in real time, but it takes only 5% in terms of the performance boost without NVIDIA Shadowplay recording versus within NVIDIA Shadowplay recording. In the end of this first benchmark, I'm going to demonstrate it for you because I already pre-benchmarked the results without NVIDIA Shadowplay recording. So throughout this video, we're going to talk a lot about Turing GPU architecture that is powering this video card, Titan RTX video card, TU102 GPU. Again, we're going to talk also Ampere GPU architecture such as RTX 3000 series video cards and RTX 4000 series video cards such as NVIDIA ADA GPU architecture. Look at this, 26 FPS, the video RAM utilization below 12 gigabytes, which is below 12,000 megabytes. You want to keep your eye at the left top corner. Titan RTX is overclocked to the maximum safest home safe environment, but if you're going to overclock any of your PC hardware components, you're doing it on your own risk and expenses. Nobody will compensate you. Okay. The system RAM utilization, you also want to keep your eye at the system RAM utilization, which will be below 10,000 megabytes or below 10 gigabytes. As again, the total system RAM utilization can be used today 32,000 megabytes or 32 gigabytes, while the total video RAM utilization can be used today above 24,000 megabytes or 24 gigabytes. As you can see, the GPU utilization is 99-100%. This means that we have the excellent GPU utilization. We are utilizing all 4,608 CUDA cores without any single CUDA core idling, which is great. And the CPU utilization, we want to keep below 90% at all the times. When it's going to reach 90% or above, that's a clear sign that you're bottlenecking throughout your CPU threads, CPU cores. You need to at least add 2 threads or 2 CPU cores. Make sure they're physical for the best possible performance and not through the hyper-threading technology when we're talking Intel CPUs. But we will never reach even 50% of our CPU utilization. Guys, keep in mind what I learned throughout the 2015 when I did the first 16K video resolution gameplay in Counter-Strike Source with my 3 Radeon R9 290 in Crossfire. I learned the higher resolution the last CPU is used, the last CPU cores and the last CPU threads is used, the more stress will be on the GPU and GPU cores. Okay, so the voltage on the CPU is crazy, 1.48 volts total to keep it stable, but it's stable without any blue screens. ultimately stable. Keep that in mind. Alright, so DirectX 9 API versus DirectX 11 API, I took it just so we can compare to provide an additional value. As again, this is going to be the world's first 16K video resolution benchmark in Unigine Heaven Benchmark. Keep that in mind. So don't forget to smash that like button. A lot of time, money, energy is invested just to support. Visit my sponsors. So I'm going to collect those pennies and I'm going to buy more video cards and I'm going to test more video cards in the future. And I'm the first YouTuber that showed you 16K video resolution all the way back in 2015 with my 3 Radeon R9 290s. Please keep that in mind. Look how small my mouse cursor right there. So the first test is over. Let me use the zoom. I'm gonna zoom in so you're gonna see the results, and we're gonna go through the results every single time. First of all, let me bring the zoom. Look at this. This is zoom under 1100%. Look how everything is so sharp. If you're gonna zoom in like this, 4K video resolution, 1100%, everything will be so pixelated. This is, yes indeed, we're rendering 16K video resolution natively. Today I'm using 8K screen, native screen, and I'm using the NVIDIA GSR, but it's rendering 16K video resolution natively and then downscaling and outputting the signal to 8K screen, okay? But it doesn't matter what it's outputting. The results will be just the same as you're running it on 16K video resolution native. So average FPS will be 25.5, score will be 643, minimum FPS 18.8, maximum FPS 42.7. This is the lowest possible preset. DirectX 9 API, tessellation disabled because tessellation is not supported under DirectX 9 API, and anti-aliasing is off. Okay, let me zoom out. I took a screenshot, so we're gonna real quick compare the screenshot. I want to show you as a fact, demonstrate it to you as a fact, that 5% performance boost if I'm not using NVIDIA Shadowplay on the same computer. But right now I'm using NVIDIA Shadowplay on this computer, so you gotta add 5%. Okay, so this is the results right here with NVIDIA Shadowplay recording. 25.5, as you already know, right? 643, 18.8 minimum, maximum 42.7. Let me real quick go ahead and show you guys. Let me close this. Let me real quick go ahead and show you the result. Same result but without NVIDIA Shadowplay recording. 26.4. So as you can see, 2 FPS will be 10% performance loss, and 1 FPS is only 5% performance loss. So go ahead and add 5% to the FPS counter to get the proper results. Alright, so we completed the first test. Let's go ahead and keep moving, guys. So now I'm going to go ahead and do the DirectX 11 API. Unfortunately, we cannot do OpenGL because, as again, after 8K video resolution, OpenGL rendering the black screen. It's doing some rendering, but it's black screen, so we cannot count that. Okay, so DirectX 11 has the tessellation option, but DirectX 9 doesn't, but I'm gonna disable it. So low preset, we're gonna run low preset. Let me disable the tessellation. Here we go. So it's going to be a great benchmark because we're gonna test 2 different APIs, the very old API, DirectX 9 API versus DirectX 11 API, which is going to be a great benchmark just to test the APIs. So guys, TU102 GPU by NVIDIA is powering today the Titan RTX video card that having 24 GB of video RAM by Samsung GDR6. Our bandwidth right now is almost 800 GB, so I increased 800 GB per second, so I increased 120 GB per second through my free overclock. Okay, and it's going to increase around 7-10% of the performance boost additionally, and it's free, so why not, right? Keep in mind that Unigine Heaven Benchmark supports SLI, and I have 2 Titan RTX video cards, and I'm going to show you 2 Titan RTX video cards in SLI over the UHDking.com. So go ahead and check it out. You don't want to miss it. It's going to be a great benchmark, and I also going to show you with the NVIDIA RTX 3090 Ti benchmark in 16K video resolution, with the NVIDIA RTX 4090 video card, hopefully with NVIDIA RTX 4090 Ti, and maybe Titan Ada in 2023, and hopefully Titan Ada or RTX 4090 Ti will be featuring 48GB of GDDR6 video RAM. It's going to be amazing if it's going to do that, because if you want to open the full potential of the Ada GPU architecture by NVIDIA in video cards such as RTX 4000 series, and especially in RTX 4000 series flagship, most definitely you want to use 48GB of the video RAM GDDR6, otherwise you're not gonna unleash the full potential, because the full potential of the Ada GPU architecture will be visible only above 8K video resolution when you're gonna utilize your GPU at 99-100%. As you can see right now, my Turing GPU architecture is utilized 99-100%. That means that almost zero CUDA cores is idling. This is exactly what we want to have. We want to utilize the GPU at 99-100%. This is excellent GPU utilization. Great FPS, as you can see, frames per second, and that MS at the right top corner stands for the milliseconds latency delay. The lower value for the MS is better, but the higher value for the FPS is better. The latency delay in milliseconds is between the hardware and software, which will be the hardware such as GPU, video RAM, CPU, system RAM, and the software will be Windows 10 Professional Operating System in our case, DirectX 11 API throughout this benchmark, and NVIDIA drivers. It's all creating the latency delay in milliseconds, so before each frame is rendered, it's exactly like 30 milliseconds, which is great result, by the way, because when I'm going to add the secondary Titan RTX video card in SLI, as again, Unigine Heaven Benchmark supports SLI, that means that we're going to cut that latency delay by 2, and we're going to improve that FPS almost by 2. But as again, I don't want to give you any sneak previews. Go ahead and check out the uhdking.com website for more great benchmarks regarding 2 Titan RTXs and SLI, especially 2 Titan RTXs and SLI in Unigine Heaven Benchmark version 4.0 under 16K video resolution that you don't want to miss. Alright, so still below 12,000 megabytes of our video RAM utilization, that means below 12 gigabytes. So most likely the Titan XP Pascal GPU architecture or Titan X Maxwell GPU architecture still can render this at the lowest possible preset, but I'm pretty sure it's not going to complete the whole benchmarks that you're gonna see throughout this video. Do that is going to be lack of the video RAM. It's not going to have enough video RAM, and I don't think it's going to have enough computing performance to complete the tests, because even on Turing GPU architecture we're almost going to render at lowest possible FPS, but still going to do in real time rendering, while I don't think that Pascal or Maxwell GPU architecture or even Titan V as Volta GPU architecture is capable to render in real time, due that Turing GPU architecture is about 40% faster than Volta GPU architecture. Anyways, as you can see, guys, the average FPS 27.2, score 684, minimum FPS 17.4, maximum FPS 47.9. Great result for the lowest possible visual preset, distillation off, anti-aliasing off, DirectX 11 API. Alright, let's go ahead and keep moving, guys. So let me real quick set now. So now we're going to use a different preset, and it's going to be, let me have a look real quick what kind of preset it's going to be. It's going to be DirectX 9 at Ultra and then DirectX 11 at Ultra. So let's go ahead and set it real quick, and we're gonna have a more talk about the GPUs. So make sure that your resolution at system, so it's going to use your desktop resolution, and in our case it's 16K UHD, but as you saw, it's not rendering white, it's rendering square, because I think it's outside of the developer algorithms and it's using just DirectX API to guess the resolution. and using height as first, and it's doing this squarish kind of rendering under DirectX APIs when it's not set as wide for the developers. As you can see, 2K resolution is the maximum due that this benchmark was released in 2009. Okay, but if you're gonna set it to system, it's possible to render it. Alright, so what I'm gonna do, so ultra preset, which is maximum visual preset, DirectX 9. Let's go ahead and keep going. Make sure the full screen is off, guys, because sometimes it's having flickering shadows, and just to not to be annoyed, I decided to do the windowed mode. So go ahead and do it like that. And full screen is not supported after the 8K video resolution anyways, because it's breaking the resolution. It's kind of rendering as square, as you can see, because as again developers didn't envision, so when you developing you want to envision. Alright, let me start the test. Wow, the mouse cursor is such a small, it's kind of hard to see. For 16K video resolution, I would say you need to have at least 120 inches screen. Otherwise, it's kind of hard to see it, guys. You gotta use a lot of Windows magnifier tool as I'm using today. 16K video resolution can be built up out of the 4 8K screens array. And you can buy right now a great 8K screen from 2021 for around $1,500, and 4 of them will cost you with the tax around $8,000, and you can have it, guys. 75-inch TV 8K video resolution from 2021 Samsung or LG costs like $1,500, so you can build up yourself a great 200-inch array of 16K video resolution out of the 4 8K screens. And on RTX 4090 video card, it is supported 4 8K screens at 60 Hz, while Turing GPU architecture is only supporting 4K. It's only supporting 8K 4 8K screens at 30 Hz. Please keep that in mind. But today I'm running 8K screen at 60 Hz while using the DSR, so it's 16K resolution at 60 Hz. But as again with the DSR, but it's still rendering in natively in 16K video resolution, and then when it's outputting the signal, it's downscaling to 8K video resolution. When you're downscaling, you're not losing the quality, you're improving, you define the pixels. When you upscaling, it's pretty bad unless you're using some artificial intelligence, DLSS by NVIDIA, especially version 3.0, which is great. It's almost as same as rendering in native resolution because every single pixel go through the artificial intelligence. Anyways, maximum visual preset, DirectX 9 API, no anti-aliasing, the average FPS 4 or 5 FPS, as you can see. Visuals is just on another level. In the end of this video, we're going to compare a little bit of the visuals. I still cannot wait to test this benchmark on RTX 4090 video card. Hopefully NVIDIA will release the RTX 4090 Ti or Titan Ada because the TU102 GPU has over 18,000 CUDA cores, while the RTX 4090 video card has 16,364 CUDA cores. Exactly, it has exactly amount of the CUDA cores as 16K video resolution 4 divided by 3 aspect ratio. But 16K video resolution as my desktop set today is 15,364 pixels, 360 pixels, which is less pixels in width than RTX 4090 video card has CUDA cores. Too bad that RTX 4090 video card featuring 24GB of the video RAM GDDR6X. It's faster video RAM, it's 1TB per second bandwidth versus 800GB per second that I'm running today on the Titan RTX after the overclock. But it's not enough of the video RAM to unleash the potentials even on all of those 16,364 CUDA cores that featured on the RTX 4090 video card. Please keep that in mind. I'm pretty sure that NVIDIA will release RTX 4090 Ti or new Titan Ada that will be featuring 18,400 34 CUDA cores, and they're going to equip it with 48 gigabyte of video RAM. It's probably going to be unregistered video RAM, due that they're using the registered video RAM on the Quadro series video cards, but Quadro series video cards doesn't consider to be any professional except it using the registered video RAM versus unregistered video RAM, but everything else will be the same as in the gamers video cards by NVIDIA. Alright, let me go ahead and zoom in a little bit. Let's go ahead and have a look. Where's my mouse cursor? My mouse cursor is such a small, as you can see right over there. So let's go ahead and zoom in. So as you can see, including NVIDIA Shadowplay recording, I'm going to have magnifier zoom tool in my screenshots, but without NVIDIA Shadowplay recording, it's going to be without it. So average FPS 4.9, great result for a single Titan RTX video card that was available for public in 2018. Score 124, minimum FPS 3.6, maximum FPS 10.6. As again, DirectX 9 API, visual quality will be ultra, no tessellation, no anti-aliasing. Great result. Alright, let's go ahead and close that. Look how small that thing, if I'm gonna zoom out that in the corner, you're not gonna even see it if you're watching that on 4K video resolution. Go ahead and watch this video on 8K screen for the best possible maximum visual experience. Switch in your YouTube player to 4320p. Alright, so next we're gonna do the same deal but DirectX 11 API. Let's go ahead and do that. The audio track that playing on the background is all rights reserved. I have the commercial license, so there is no royalties can be claimed. Please keep that in mind for the audio track. It's not provided by YouTube. It was purchased by me from the local composer. Alright, so let me real quick go ahead and start the benchmark. We're gonna start the benchmark. Here we go. The visuals is on another level. However, I'm not using the tessellation yet. When I'm going to use the tessellation, you're going to see that bump mapping on the ground, on the terrain, will be improved by another level due to that tessellation. Let me explain for those newcomers. Tessellation feature that is available under DirectX 11 API and newer APIs by the Microsoft pretty much is splitting the triangle or polygon into multiple polygons or triangles, and it's pretty much defined the 3D mesh, 3D model, or a 3D primitive that is loaded into this 3D scene. The Unigine Heaven Benchmark developers didn't use the tessellation on every single 3D model. They only applied the tessellation on terrain and few of the 3D models that we're gonna see throughout this 3D scene. 3D surface, 3D world, 3D benchmark. It's all called differently. It depends what kind of APIs you're using. In the end of this video, I'm going to demonstrate to you as a fact that 16K UHD, not UHD, but 16K 4 divided by 3 aspect ratio, 16K video resolution is the maximum video resolution that is possible in 2023 on all kind of commercial and open source APIs such as Vulkan API, DirectX API, OpenGL API, OpenCL API, CUDA API, Mantle API. I'm going to demonstrate you guys to you as a fact. So pretty much 16K video resolution is the maximum renderable video resolution in real time in all of those APIs, commercial or open source APIs. Keep that in mind. So whenever you see 32K video resolution rendering in real time, it's all fake, especially under DirectX API or Vulkan API or OpenGL API. So ignore that. I'm going to demonstrate to you as a fact why it is. Look, everything is looking on another level. It's just unbelievable. So guys, as you can see that Turing GPU architecture, TU102 GPU that is equipped in our Titan RTX video card by NVIDIA is using 4608 CUDA cores. Sometimes they also call the shader cores or unified shader cores for the AMD Radeon video cards and AMD technologies, 3D accelerating technologies. And it's a lot, guys, but when compared to the RTX 4090 video card or full TU102 GPU, which is 8 GPU architecture, 2 generation from this generation of the Turing, it will be, guys, 4 times more CUDA cores on that video card. And I believe that even the RTX 4090 video card, which is not the full TU102 GPU, will deliver 4 times in terms of the performance boost when the GPU will be utilized 99% or 100%, and I don't see a reason why it's not going to be utilized at 100% under the 16K video resolution. So I cannot wait to put my hands on the RTX 4090, but hopefully it's going to be a flagship of the full TU102 GPU, such as RTX 4090 Ti or Titan Ada. We're gonna find out. It's going to be released in March, I believe, of 2023. Based on the NVIDIA manuals that I was reading about the full TU102 GPU. Anyways, as you can see at the left top corner, your eyes should be at the left top corner while you're listening to me. So at the left top corner, our video RAM utilization is almost 15,000 megabytes or 15 gigabytes. And our system RAM utilization just smashed the 10,000 megabytes or 10 gigabytes. But it's still a healthy video RAM utilization. I believe that we are floating zero data from a video RAM into the system RAM. We are only loading the necessary data into the system RAM. So when the system RAM utilization will go way above 10,000 megabytes or 10 gigabytes, that's going to be a clear sign for you throughout our test that we are loading some data by those CUDA cores from a video RAM into the system RAM. Alright, so let me real quick go ahead and zoom in. So we're done with this test. And so as you can see, under DirectX 11 API, pretty much the same deal. 4.9 FPS average, score 123, minimum FPS 3.2, maximum FPS 8.5. Okay, while using the ultra visual preset, no anti-aliasing, no tessellation. Let me close that. Let's go ahead and restart the benchmark. Now we're going to use a different preset, and I believe we are done with the DirectX 9. And now we're going to use the tessellation, which will be a feature that is available as Microsoft classes under DirectX 11 API or newer APIs. So let's go ahead and verify real quick. DirectX 11 Ultra done. Now we're gonna go, we're gonna go DirectX 11 API, lowest possible visual preset, and moderate under the tessellation. Let's go ahead and set it, guys, that way. So low visual preset, tessellation moderate, which is low tessellation, but still you're gonna see a big difference when we're gonna splitting some polygons by defining some 3D meshes, 3D models, 3D primitives on the 3D scene. So this is how we're gonna do it, guys. Let's go ahead and keep moving. Alright, so let me see. Here we go. Put that, and we're gonna real quick and execute the benchmark. Here we go. As you can see now, you can see the difference when tessellation at moderate, that is more defined on terrain, on the ground, versus the bump mapping parallax technique, which was kind of like a stones, like a rocks, but it was, you can see it, that it's not a physical 3D mesh. Right now it's much better visual effect to it through the rasterization, while the 3D mesh is defined as not through the textures but through the details while dividing the polygons or triangles. It depends what kind of game engine you're using. Today this Unigine Heaven Benchmark is using Unigine game engine, the same game engine that was powered the Oil Rush PC game, which is great game, guys, available for free on Steam. I advise you, if you're a real-time strategy fan, go ahead and download it. It's completely free. It's a great strategy. You're gonna have a lot of great time, especially as a single player, but it's also supporting the multiplayer. It's a great visuals, great game, and it's available for free. I would say 5 out of 5. Highly recommend. I'm also going to demonstrate Oil Rush PC game in 16K video resolution over the UHDking.com YouTube channel. But that game is, you can scale to the wide resolution, versus the Unigine Heaven Benchmark is not scalable, as you can see, because the Oil Rush PC game was released after the Unigine Heaven Benchmark, and I believe the developers kind of did some improvement in that game engine. It's powered by the newer game engine, the whole game, Oil Rush PC game, which is again beautiful game. It's kind of in a C, real-time strategy. Highly recommend for any RTS fan. Alright, guys, so great FPS. As you can see, the tessellation for the Turing GPU architecture is not a big deal, almost about the same FPS at the left top corner, but we're going to utilize more of the video RAM. So video RAM at the lowest possible preset is almost 12,000 megabytes, which is 12 gigabytes. As again, I believe that Titan X Maxwell GPU architecture or Titan XP's Pascal GPU architecture is still capable to render this at the lowest possible preset. For those who are curious about the previous GPU architecture, such as Titan X Maxwell GPU architecture or Titan XP Pascal GPU architecture, I have them in 4-way SLI, 4 video cards in SLI, 2 video cards in SLI, 3 video cards in SLI benchmarks, and especially in Unigine Heaven Benchmark in 8K video resolution is available over the UHDking.com. Go ahead and check it out. You don't want to miss that video. It's going to be a great video for you to watch, to compare. I'm also going to test single Titan RTX and 8K video resolution. 12K video resolution will be available for you over the UHDking to watch. I also will try to do the 4K video resolution, and as again I will try to do 2 Titan RTXs and a SLI before we're gonna switch to a newer GPU architectures and newer video cards. Okay, the CPU utilization never showed the 50% of CPU utilization. That means that we are not bottlenecked by our CPU. We are going to be CPU threads or CPU cores. We are going to only be bottlenecked through our CPU frequency, which is instruction per clock. Frequency is pretty much instruction per clock. So that means that newer CPU technologies and architectures will bring higher instruction per clock of the external instruction clock, and it's going to bring higher FPS and higher performance boost even when it's going to run the same frequencies. But the Intel Core i9-9900K today overclock at 5.3 GHz pretty much is pushing its boundaries in a home safe environment overclock, and it's free. So right now pretty much I would say that you're watching the maximum capabilities from the technologies from December 2018. Do that Titan RTX was available in December 2018, as well as Intel Core i9-9900K. Alright, so 26.4 FPS, score 664, minimum FPS 16.7, maximum FPS 47.9. And as a reminder, this is DirectX 11 API with the lowest possible visual preset without any anti-aliasing, but with the tessellation at moderate level, which is lowest possible preset. Alright, let's go ahead and close that and let's go ahead and keep moving. I believe that we're gonna test now extreme tessellation, if I'm not mistaken. Let's go ahead and verify that. As you can see, I already pre-benched the results without NVIDIA SharePlay recording. So now we're gonna do lowest possible preset, DirectX 11 API Extreme. And as again, DirectX 9 API doesn't support the tessellation. Please keep that in mind. It's pre-built classes by Microsoft under DirectX 11 API. So let's go ahead and switch to Extreme. Where is the benchmark? Here we go. So tessellation will be under extreme. It's still going to be under the low visual preset. I decided to test all kind of different resolutions, all kind of different presets to set the first point of data towards the 16K video resolution benchmarking in Unigine Heaven benchmark that we're going to use a lot throughout the future and newer video cards. Keep that in mind. Alright, let's go ahead and run this. Where's my mouse cursor? That mouse is such a small right there. Let me move it up a little bit like that, and we're gonna execute the benchmark. Here we go. As you can see, tessellation at extreme defined at terrain, and now it's photorealistic and believable that this is real rocks, real stones right there on the ground. So parallax bump mapping techniques are nice, but the tessellation, when you actually not bringing the details through the textures but bringing the details through the defining the models, 3D primitives, the polygons on that 3D meshes is actually a big deal, as you can see. And it's not taxing a lot of the FPS while doing so on a Turing GPU architecture. But I remember the Titan X Maxwell GPU architecture tessellation was a big deal. Even with 4 Titan X Maxwell GPU architecture in SLI, the tessellation was a big deal. Go ahead and watch the 8K video resolution benchmarks on 4 Titan X Maxwell GPU architecture over the UHDking.com. Look at this, the video RAM utilization is still below 12,000 megabytes, which is 12 gigabytes. The system RAM utilization is healthy, which is the maximum what we find out going to be 10,000 megabytes or 10 gigabytes on a system RAM. The FPS is also great under the extreme tessellation. I know that we are not applying the tessellation to every single 3D mesh, 3D model, 3D primitive, but we are applying it to some 3D meshes, 3D primitives such as landscape, terrain, such as dragon. As you can see right now, it's such a defined, every single detail right there in that dragon, versus when it was at the low without the tessellation, it was like plain simple. Great FPS, as you can see. I really like that FPS on Turing GPU architecture with the tessellation. Just chewing that tessellation like it's nothing, but actually right now we're rendering much higher polygon counts on the scene, on the 3D scene, 3D surface than we did without the tessellation. I would assume about 20% higher in terms of the polygons count on the whole 3D surface, 3D scene, 3D world. Alright. Still above 20 FPS average, and as again, you gotta add 5% to the FPS counter to get the FPS without NVIDIA Shadow Play recording. Just because we are using the lowest possible preset on the visuals, as you can see, it's kind of blurring out some pixels on the textures, so it's not bringing the textures with the full pixels on it. Cannot wait to test it with the ultra visual preset, which will be the maximum visual preset. So it's not going to use the artificial algorithms while it's going to blur out some pixels, while going to use the lower video RAM usage and not going to bring the full details of those textures. Cannot wait to bring all the details of those textures, and it's going to be possible in this Unigine Heaven benchmark under the ultra visual preset, and we're going to test it under ultra visual preset in about few minutes. So guys, the full ADA GPU architecture flagship TU102 will be featuring unbelievable amount of the CUDA cores. Amount of the CUDA cores on a full TU102 GPU will be 18,432 CUDA cores, which is way above value that we are having in 16K video resolution 4 divided by 3 aspect ratio, which will be 16,364 pixels in width. So it just, the NVIDIA is pretty much showing us a clue that ADA GPU architecture or RTX 4000 video card is designed to render 16K video resolution in real time, because it has the amount of the CUDA cores way above that 16K video resolution in width amount of pixels. Alright, let's go ahead and zoom in, and let's go ahead and have a look. Where's my mouse cursor? Right there. Such a small, it's kind of hard without the magnifier tool. As again, if you're running 16K video resolution, you want to make sure to run at least 120 inches or above to be able to see the mouse cursor and see everything on the screen, and sit like 1 meter or 2 meter away. Alright, so average FPS 25.4, score 639, minimum FPS 16.3, maximum FPS 46.7. As a reminder, this is DirectX 11 API, lowest possible visual preset on visuals, and tessellation at extreme with no anti-aliasing yet. Let's go ahead and set the preset to a different preset now. So after the low on extreme tessellation, we are going to use what? We're going to use the high visual preset with extreme tessellation, DirectX 11 API. Let's go ahead and do that real quick. Okay, so instead of low, high, so almost maximum visuals, but I would say only 90% visible pixels rendered. At ultra will be 100%, but extreme tessellation, let's go ahead and test that. Let me move our window here all the way here and start the benchmark. Here we go. Started the benchmark. So guys, either GPU architecture, TU102 GPU by NVIDIA, the flagship, will be featuring 96 megabytes of the level second cache on the GPU. Let me explain to you the internal of the GPU and what is the level first cache, level second cache. So level first cache on the GPU, on NVIDIA GPU architecture, is used pretty much for the physical addressing, and on the Titan RTX video card TU102 GPU is only 64 kilobytes of the kilobytes, not kilobits. Kilobits times 8 will be amount of the kilobytes, okay, and plus 36 kilobytes of additional, which will be 96 kilobytes of total level first cache on the Turing GPU architecture TU102 GPU. But those level 1 cache is used for the physical addressing. So some details, some information, some data. So let's say I'm pulling right now some textures, and where this textures is located is pretty much stored in that physical addressing, the physical address of those textures, and then it's mimicking into the virtual names, and then it's having that fast access to the virtual name, so it don't have to every time refer to the full address of the URL where it's located on a local storage device. So then it's computing through the CUDA cores some data and storing into level second cache. That level second cache is pretty much used for the storage of the data, and then video RAM is the slowest storage after the level first cache, which is the fastest, but as again it's not used a lot for the data. Level second cache a little bit slower than level first cache, and then video RAM is much slower than level second cache. And when video RAM is overloaded, then it's using the system RAM to store some data from the GPU, and when the system RAM is overloaded, it's using some storage to store some data, which is the slowest possible pre-caching, let's call it like that. NVIDIA GPUs are using two-way pre-caching, level 1 cache and level 2 cache, if video RAM is not pretty much counted as the pre-caching, because video RAM can be accessed through the NVIDIA SDK by the CPU as well if needed. You can develop a program and software that are going to access the video RAM for its CPU needs, while the level 1 cache, level 2 cache is locally allocated for the GPU. So we can say that NVIDIA GPUs and NVIDIA video cards are using two-way pre-caching, level 1 cache and level 2 cache, while an AMD video cards, Radeon video cards, are using three-way pre-caching, such as level 0 cache, level 1 cache, and level 2 cache. Before it's using the video RAM. Hopefully guys I explained it to you. So level first cache on the GPU is the fastest, and level first cache is used by the streaming multiprocessors, and those streaming multiprocessors having some CUDA cores in each streaming multiprocessors, the same amount of the CUDA cores per streaming multiprocessor. On the Turing GPU architecture, there is a total 72 streaming multiprocessors. You're gonna pretty much all what you gotta do, you gotta divide 4,608 CUDA cores, the total CUDA cores that is on the TU102 GPU on our Titan RTX video card, by 72 streaming processors. Let me actually go ahead and do that. Let me bring the calculator. We're gonna do it. So we're gonna do some mathematics, and it's going to be much better for the newcomers to understand the information that I'm providing. 1 second. Let's go ahead and real quick take a screenshot, start the new benchmark, and we're going to talk about the GPU architecture. So I'm going to provide you additional value as I promised to you. So you're going to be knowledgeable about the video cards, GPUs, CPUs, and all the internal processors after watching this video. So don't forget to share this video with your friends, so they're going to have some clues as well. So average FPS 6.8, score 173, minimum FPS 4.2, maximum FPS 17.8. This is on, as a reminder, on the DirectX 11 API. The quality will be high, visual preset, and tessellation will be extreme with no anti-aliasing used yet. Okay, let's go ahead and close that down. Here we go, here we go, here we go. And close it down. Let's go ahead and start the new benchmark. Unigine Heaven Benchmark was developed by the post-Soviet developers, Ukrainian, Russian, Belarus developers. But I'm supporting Ukraine in Russian war in 2022. Those bastards attack Ukraine. I'm 100% supporting Ukraine. I'm supporting Ukraine 100%, guys. So now we're gonna go ahead and use the ultra preset. So it's going to be DirectX 11 API, ultra preset, tessellation, and extreme. No anti-aliasing yet. Let's go ahead and start the benchmark, and we're gonna talk more about GPU architecture in a few seconds. Let me bring this window all the way here and start the benchmark like that. Here we go. Started the benchmark. Okay, we got the benchmark running. Look at this defined landscape. It's just beautiful, those level of details. I believe they split it by 4 or by 3 those triangles, those polygons. Anyway, so as I told you that Turing GPU architecture has 72 streaming streaming multiprocessor units, but where's my mouse cursor? 1 second, guys. I'm trying to calculate here on the calculator right there. So the total, so how to find out how many CUDA cores, CUDA shader cores, you can call it like that, in each streaming multiprocessor unit. So the total CUDA cores on the Titan RTX video card, 4,608. Please watch this video at least in 4K video resolution, but the best visual experience will be under the 8K UHD 4320p, and NVIDIA Shadow Play and NVIDIA driver is modified today, so I'm recording in 8K video resolution. Even on Turing GPU architecture that is supporting 8K video resolution recording on the NVIDIA Shadow Play, but was locked by the NVIDIA unlocked 8K video resolution through the NVIDIA Shadow Play through the AV1 codec under the RTX 4000 video cards, but I'm using the modified version. As again, 4,608 CUDA cores total divided by 72 streaming multiprocessor unit. 72 divided by 72. So each streaming multiprocessor unit has 64 CUDA cores. Those 64 CUDA cores has 64 kilobytes per streaming multiprocessor unit. That means that 1 kilobyte can be accessed by each CUDA core throughout its operations. Keep that in mind. So when it's doing some manipulation with the pixel, like post-processing manipulation, it can access 1 kilobyte of data through the level first cache, which is the fastest possible cache. However, the same CUDA cores can access the level second cache, but level second cache on each GPU by the NVIDIA is shared throughout all the CUDA cores, throughout all the streaming multiprocessor units. Okay, so 1 kilobyte per CUDA core can be used theoretically and in practically as well on a Turing GPU architecture, right? So let's go ahead and calculate how much level first cache is used on the AIDA GPU architecture, which is RTX 4000 series video cards. So TU102 GPU has 18,432 CUDA cores. 18,432. Guys, don't worry, the calculator is only using like 1% of my CPU. It's not gonna reflect the FPS. 842 CUDA cores, okay, and it having it has the TU102 GPU by NVIDIA has 144 streaming multiprocessors. So 1 divided by 144. So each streaming multiprocessor unit has 128 CUDA cores. Double CUDA cores on AIDA GPU architecture versus the Turing GPU architecture. So this is additional information for you. And 128 CUDA cores per each streaming multiprocessor unit, but a level first cache on the AIDA GPU architecture is also 128 kilobytes per streaming multiprocessor unit. So that means still the same 1 kilobyte per CUDA core can be used on AIDA GPU architecture. So there is not such a difference. Turing versus the AIDA GPU architectures by NVIDIA. Let me, guys, we just finished the benchmark. Let me zoom in, take a screenshot. And we're gonna continue on GPU architecture. So average FPS 4.8, score 120, minimum FPS 3.1, maximum FPS 8.4. As a reminder, DirectX 11 API, Visual Preset Ultra, Tessellation Extreme, no anti-aliasing yet. Okay, let's go ahead and close this down. Where's my mouse? Right there. Let's go ahead and close this down. So the next test should be, if I'm not mistaken, with anti-aliasing. Let me go ahead and double check. So we did Ultra Extreme, now Ultra Extreme 2 times anti-aliasing. Okay, let's go ahead and do that. So let me go ahead and preset it. So anti-aliasing 2x, Extreme Tessellation, Ultra Visual Preset, DirectX 11 API. I'm also going to show you at low Visual Preset as a bonus, without tessellation and within the tessellation, just to find out the difference in the CPU versus the GPU performance under the 16K video resolution. This is going to be an extra bonus for those people that ask me to test lowest possible presets. So don't forget to smash that like button, guys. This is for you, an extra bonus. So let's go ahead and start this benchmark, and we're going to continue to our talk to GPU architectures. So let me bring it here. I'm going to start the benchmark. Here we go. Started the benchmark. As you can see, it's rendering in 16K video resolution natively. It's just beautiful. Alright, so the level 1 cache per each CUDA core is pretty much will be the same as an ADA GPU architecture by NVIDIA or Turing GPU architecture by NVIDIA. So there is not such a big difference. But level 2nd cache that can be utilized by all the CUDA cores shared, whatever they needed. It's not dedicated to the each streaming multiprocessor unit, will be on TU102 GPU, Turing GPU architecture by NVIDIA, that powering today our Titan RTX will be 6 megabytes. Okay, so it's 6 megabytes, right? On the RTX 4090 video card, which is not the full 8102 GPU, will be 72 megabytes. So it's 12 times more of level second cache on the ADA GPU architecture versus the Turing GPU architecture. So 12 times more on the RTX 4090 video card that is not the full 8102 GPU, and it almost has 4 times more CUDA cores. So we have 12 times more level 2nd cache while we're having 4 times more, almost 4 times, it's like 3.75 times more CUDA cores. That means, guys, that we have a solid advantage. But let's go ahead per each CUDA cores utilize of that level 2nd cache before it's going to get access to the video RAM to store some data when the level 2nd cache will be overloaded. But let's go ahead and talk about the full AD102 GPU, ADA GPU architecture by NVIDIA, that's going to be RTX 4090 Ti or new Titan ADA. It has the full AD102 GPU. It has 96 megabytes level 2nd cache. So versus the 6 megabytes of the level 2nd cache on Turing GPU architecture Titan RTX video card, let's divide it by 6. We are exactly by 16 times more level 2nd cache can be used by those CUDA cores. But what is the advantage of the CUDA cores? 16 times. So we're having 16 times more level 2nd cache. Remember that value, okay? So what is the advantage? How many CUDA cores? 8102 versus TU102, which is Turing GPU architecture. So 8102 having 18,432 CUDA cores divided, this is ADA GPU architecture, flagship RTX 4000 series, divided by Turing GPU architecture flagship such as Titan RTX, which will be TU102 GPU, divided by 4608. And what will be advantage? I know, but just to demonstrate it for you, the advantage will be, guys, by 4 times. So ADA GPU architecture such as flagship AD102 GPU, which is probably RTX 4090 Ti or Titan ADA, has 4 times more CUDA cores than Turing GPU architecture flagship such as Titan RTX video card or TU102 GPU, which is Quadro RTX 6000 or Quadro RTX 8000 video cards. In terms of the commercials, but there is not such a big difference. They're not called professional. The only thing that is professional will be the registered video RAM on the Quadro RTX 6000 and RTX 8000 video cards that will be powered by the same TU102 GPU versus the unregistered video RAM on the Titan RTX video card. And what will be the difference? The difference will be that Quadro video card cannot do any mistakes while storing the data into the video RAM, while the Titan RTX under the heavy overloads can do the drop data before storing into the video RAM. Okay, let me zoom in real quick. We're done with our benchmark. Take a screenshot, review the results, and we're gonna come back to our talk. So average FPS 4.6. Wow, that's a great result. With the 2 times anti-aliasing, there is no such a big deal, as you can see. Score 115, minimum FPS 2.9, maximum FPS 8.0, but there is a possibility maybe under the 16K video resolution that anti-aliasing doesn't work correctly. Could be a possibility. Okay, so I took the shot. Let me go ahead and close it down, guys. Here we go. One second, where is my mouse cursor? Right there. Let me close it down. And now, before to show you 4x anti-aliasing, I want to real quick show you the lowest possible preset. DirectX 11 API with 2x but low preset with the tessellation extreme and then without the tessellation. Let's try first with the tessellation. This is an extra bonus before I'm going to switch to 4x anti-aliasing, just in case if we're going to stop the recording, because somehow the NVIDIA shadow play sometimes reflecting in the Unigine Heaven Benchmark. So this is going to be the second time I'm re-recording this video because it stopped the video recording when I used the 4 times anti-aliasing. So hopefully it's not going to do it while I was recording with NVIDIA Shadowplay. It was absolutely fine without NVIDIA Shadowplay recording. So somehow it's using a little bit of CUDA cores and some components on the video card through the Unigine Heaven Benchmark while it's using it under the NVIDIA Shadowplay recording while it's recording in real time on the same computer. So let's go ahead and try that. So pretty much low preset, same presets but low visual preset. 2 times anti-aliasing, just to show you the difference. This is going to be more like a CPU test, but as again, you cannot call the CPU test under the 16K video resolution. Please keep that in mind. But just for those who's curious, an extra bonus. A lot of people was asking me, and just because this is the first point of the data towards 16K video resolution benchmarking vector, so let's go ahead and have a look. So I'm still benchmarking. So the amount of the CUDA cores on either GPU architecture, let's come back to our GPU architecture, is 4 times more on the flagship of the either GPU architecture RTX 4000 series or Titan Ada versus the Titan RTX video card, which is the flagship on the Turing GPU architecture, TU102 GPU, right? 4 times more CUDA cores, but 16 times more level second cache that can be used by those CUDA cores. So let's go ahead and do calculations. 16 divided by 4. As you can see, my mouse response is faster now than it was under the ultra visual preset with extreme tessellation. So it's stressing the computer right now at hard. Not right now, but when I use the ultra visual preset. Right now it's kind of nice. So 16 divided by 4 is going to be 4. Okay, so we have, guys, we are having 16 times more level second cache, okay, advantage versus the Turing GPU architecture, or we can utilize the 4 times more level second cache per each CUDA core versus the Turing GPU architecture on either GPU architecture versus the Turing GPU architecture. When those CUDA cores getting access, let's say they getting access exactly, each CUDA core receives the same amount of the level second cache, but it's not going to happen like that because it's shared. But let's assume that scenario. Let's assume that we're having a perfect parallel computing benchmark, and we're getting advantage of 4 times more level second cache per each CUDA core allocated if this will be the scenario on either GPU architecture versus the Turing GPU architecture. So what I'm assuming, guys, I'm assuming that not only the flagship of the either GPU architecture will be 4 times faster when the GPU will be utilized at 99-100% versus the Turing GPU architecture, such as TU102 GPU, that 8102 flagship will be 4 times faster. But I also can assume that RTX 4090 video card will be at least 4 times faster versus the Titan RTX video card, due that it has the 4 times advantage of the level 2nd cache per each CUDA core, while the level 1st cache will be equal 1 kilobyte per CUDA core when it's perfectly utilized. Okay, but as again, it's not shared between each CUDA cores, but it's split into stream and multiprocessor unit. But as we calculated, as I explained to you perfectly, it's 1 kilobyte per second on level 1st cache per each CUDA core when it's doing some manipulation with each pixel through some post-processing. Alright, so also I played with the CUDA manual and while was developing my CPU ray tracing benchmark. Keep in mind that I'm going to, guys, release very soon my CPU ray tracing benchmark when we're going to test our CPUs. Hopefully it's going to be very popular like 3D Mark. But I was also getting I was reading some information about the CUDA and in 2022 and ADA and Turing GPU architecture throughout that manual that was released by the NVIDIA. For those who's curious, go ahead and do the Google search CUDA manual with C, and you're gonna see it when they explain the GPU architecture like I'm explaining to you right now. And what I find out that level 1 cache on the ADA GPU architecture is around 6 terabyte per second bandwidth. It's like 4.9 terabyte per second / 6 terabyte per second bandwidth under the CUDA micro benchmark. Keep that in mind. This is on the ADA 8102, the full 8102 GPU flagship that will be used on the Quadra video cards that based on ADA, and most likely on the Titan ADA or RTX 4090 Ti. Okay, 1 second, let me pause that. So FPS 20.2, score 509, minimum FPS 12.7, maximum FPS 35. And as a reminder, this is under DirectX 11 API. The quality visual preset was low, distillation was extreme, 2 times anti-aliasing. All right, let's go ahead and close that. I'm gonna real quick do the benchmark one more test on the low preset without the tessellation, but still with 2 times anti-aliasing, so you can see the relationship of the CPU and GPU under the heaviest possible visual preset, but with the lowest possible visual preset, but under the heaviest possible maximum resolution that is possible in the games 2023 on all kind of commercial and open source APIs, 3D rendering real-time APIs. So we're gonna turn down the anti-aliasing. Lowest preset DirectX 11 API, 2 times anti-aliasing, but turn down the tessellation, sorry. Okay, so let's go ahead and start the benchmark. Let me move this window, and we're gonna come back to our GPU architecture information that I'm going to share with you that I got experience on. Alright, so I'm benching. So yeah, so I was reading throughout that manual. I didn't benchmark it, but based on NVIDIA information through the micro benchmark of the CUDA under the C compilation, that level 1st cache on the ADA GPU architecture by NVIDIA will be 4.9 terabytes per second - 6 terabytes per second. Can you imagine that bandwidth? While a Turing GPU architecture had 1.7 terabytes per second level 1st cache bandwidth, while the Ampere GPU architecture 8102, which is the RTX 3000 series video cards such as flagship 8102 RTX 3090 Ti video card and Quadras based on the Ampere GPU architecture flagships will be showing 3.7 3.2-3.7 terabyte per second level first cache bandwidth. Okay, so this is how fast the level first cache on the Turing GPU architecture, Ampere GPU architecture, which is RTX 3000 series video card, and Ada GPU architecture, which is RTX 4000 series video cards. And Turing GPU architecture is RTX 2000 series video cards, such as RTX 2080 Ti, but RTX 2080 Ti had 256 CUDA core last, and it was not the full TU102 GPU as Titan RTX video card. Okay, so level second cache based on that manual is absolutely amazing as well. It's going to be, guys, I'm sorry, that the data that I provided to you will be level second cache, not level first cache. Level first cache is unavailable. How fast it is, nobody knows. It's all about level second cache. Sorry about when I was saying level first cache. It's level second cache. So Ada GPU architecture has 4.8 terabytes per second / 6 terabytes per second. It's like, depends how well the CUDA core is utilized. At 100% utilization, level second cache on Ada GPU architecture, RTX 4000 series flagship video cards AD102 by NVIDIA will be 6 terabytes per second bandwidth. So you can imagine the video RAM GDDR6X on the Ada GPU architecture is 1 terabyte per second. You can imagine how fast the level second cache, 6 terabytes per second on the full load. Nobody knows how fast the level first cache. I don't know how to test it. I don't know the great resources where you can read up. But Ampere GPU architecture is again 3.2-3.7 terabytes per second level second cache, which is RTX 3000 series flagship, RTX 3090 Ti, and Quadras flagships GA102 GPU by NVIDIA. And Turing GPU architecture level second cache is 1.2 terabyte, 1.7 terabytes per second. Okay, while the video RAM on Turing GPU architecture in our Titan RTX video card is 672 gigabytes per second bandwidth, but it's right now it's overclocked to 800 gigabytes per second. So you can see how fast the level second cache versus the video RAM. And system RAM today that I'm using, DDR4, will be 50 gigabytes per second at its peak as a maximum bandwidth, but it's like 48 gigabytes, which is 48,000 megabytes, as you saw throughout our benchmark under the Ada 64. So you can see, and the storage, of course, is not going to be even the 10 gigabytes per second. And storage is the last resort when the GPU is storing its data, when the video RAM will be overloaded. So first the level second cache overloaded, then it's going to use the video RAM, and then when video RAM is overloaded, it's going to use the system RAM. Okay, and when the system RAM is overloaded, which is almost 50 gigabytes per second bandwidth, then it's going to use the system storage, which will be way below 10 gigabytes per second. In my case, it's going to be like 600 megabytes per second. Okay, so you can see how the GPU handling the pre-caching. First 2 ways on the NVIDIA and 3 ways on the AMD. AMD is again level 0 cache, level 1 cache, level 2 cache, and then video RAM, then system RAM, and then the storage. I explained it to you guys for those newcomers. Hopefully it brought a lot of value to you. As again, average FPS 22.9, score 577, minimum FPS 15.6, maximum FPS 36.8. As a reminder, this is under DirectX 11 API. Lowest visual preset distillation is disabled, but with 2 times anti-aliasing. So we got those type of results, right, guys? Let me close the benchmark. I'm gonna go with you real quick on all of the benchmark data before we're going to jump into the 4x anti-aliasing, and we're gonna test it. Hopefully it's not going to freeze on us. So all those tests was taken with the 1 second, guys. Look like I lost. Here we go. With NVIDIA Shadow Play recording. So this is, guys, the, let me zoom out so you're gonna see. Remember that I took the screenshot. So as again, I'm just gonna go through those things. You can see self-explanatory within NVIDIA Shadow Play recording. Pause that. This is the results before we're gonna go to 4 times anti-aliasing, which will be the maximum stressful benchmark, and 8x is not possible on Titan RTX video card with 24GB of video RAM, but I believe we're just going to be struggling through the video RAM. Maybe it's going to be possible on EDA due to a lot of level second cache. Maybe it's not. Maybe we're still going to be limited with 24GB of video RAM, but hopefully EDA will introduce 48GB of video RAM on a flagship of the TU102 GPUs and video cards. Okay. Okay, guys, this is the presets. Let's go ahead and keep moving. Let me show you presets. I showed you the presets, and now I'm gonna go ahead and give you an extra bonus with 4x quality low, DirectX 11, and without the tessellation, and then within the tessellation low preset visual quality, and then with the ultra visual preset within the tessellation. So 3 more tests as extra bonus is coming out, just to underline the whole data on the Turing GPU architecture and the world's first 16K video resolution benchmark in the Unigine Heaven Benchmark 4.0, as you can see, as a first point of the data towards 16K video resolution benchmarking vector. So guys, I explained to you the architecture and why I'm thinking that even the RTX 4090 video card will deliver 4 times more performance over the single Turing GPU architecture TU102 GPU, that is Titan RTX video card. Due that pretty much it has very fast level second cache. 4 times more of the level second cache can be allocated per each CUDA core, which is unbelievable, and or 16 times more versus the Titan RTX. But if this was the Turing GPU architecture CUDA cores, those 18 those CUDA cores was not the EDA GPU architecture, but let's say that's why when they calling the CUDA cores Turing GPU architecture CUDA cores versus the CUDA cores EDA GPU architecture, the reason of those CUDA cores will be in design of the CUDA cores of the level 1 cache and level 2 cache. This will be the reason between, and the bandwidth of the data transfer that is capable on that level 1 cache and level 2 cache. That will be the difference. While you wanna while you cannot compare CUDA cores of the Turing versus the EDA, because the level 1 cache size, bandwidth per second, hopefully guys this makes sense. But if the 18,432 CUDA cores was on the Turing GPU architecture, which is 4 times more, it should be 24GB of level second cache. It would be a design of the Turing CUDA cores, okay, by NVIDIA. But just because it's design of the EDA CUDA cores, which is cannot be compared, as again, it's 96 megabytes, which is 4 times more when compare level second cache of the when compare level second cache of the Turing GPU architecture versus the EDA GPU architecture. Either GPU architecture receive 4 times more if the architecture will be compared, even if the Turing would have 18,432 CUDA cores. Ada is still dominating by 4 times more per each CUDA core of level second cache. Hopefully guys, I explained it to you, I calculated and explained it to you well. Do that. If it would be 18,432 CUDA cores of the Turing, it would be 4 times of the 6 megabytes of the level second cache. 24 megabytes of the level second cache will be allocated for those 18,432 CUDA cores of the Turing versus the 18,432 Ada CUDA cores is allocated 96 megabytes of the level second cache, which is 4 times more access per each CUDA core, even if it's shared. But let's assume the perfect scenario when every single CUDA core receives and store and read the same amount of data per CUDA core and requires the same amount of the level second cache. Let's say if it wasn't shared, but it could allocate for one CUDA core like 2 megabytes versus the second CUDA core like 128 kilobytes. Hopefully guys this makes sense because it's shared. But let's assume the scenario when it's equal per each CUDA cores. It's 4 times more Ada CUDA cores in architecture versus the Turing architecture CUDA cores. So I explained it to you guys, everything what you need to know. Now we're gonna go ahead and back into the data at the left top corner. Where is that? 1 second. Where is the... Here we go. And we're gonna pay our attention to the maximum stress with anti-aliasing and maximum visuals in this benchmark. So as you can see, FPS, average FPS 18 FPS, score 453, minimum FPS 11.5, maximum FPS 31.3. A visual preset low, tessellation disabled, which is off, and anti-aliasing 4 times AA. Unbelievable guys, okay? Now let's go ahead and put the tessellation to extreme, but still at lowest possible preset, just to see the difference on Turing GPU architecture before we're gonna compare the difference of the benchmark with the different GPU architectures in the future over the UHDking.com. As you can see guys, a lot of computer science experiments provided to you, a lot of data, a lot of information and skills shared. So hopefully you learned a lot throughout this video. So tessellation will be on a maximum extreme, but still low preset, 4 times anti-aliasing, just to see what's the difference tessellation under this benchmark on Turing GPU architecture versus the future GPU architecture, and how well the future GPU architecture can handle the tessellation methods. Okay. I'm going to start the benchmark. Here we go. And now we're going to pay our attention, our eye, at the left top corner. As you can see, the video RAM utilization still at lowest possible visual preset, that is not utilizing to the maximum our video RAM, will be almost 18,000 megabytes of our video RAM utilization. The system RAM utilization is still healthy, still below 11,000 megabytes. So as you saw before, 10,000 megabytes of our system RAM utilization is a healthy system RAM utilization. So this is a clear signal that we are not offloading any data from a video RAM into the system RAM. Okay, but we still required 18,000 megabytes of the video RAM to be able to run it, this particular benchmark right now with this particular presets. And keep in mind, as again, AMD video cards will be using about 30% less of the video RAM, because the AMD Radeon video cards is using much better texture compression algorithms versus the NVIDIA. It's a little bit different approach. Okay, So AMD video card was, even with the 12 gigabyte of video RAM over here, will be Gucci and will be able to run this benchmark, but it's not going to have enough GPU computing performance power to do that. AMD flagship video card is barely touching the RTX 4080 video card, okay? But it still can do that, guys, actually, because it's going to be faster than Turing GPU architecture. So on this particular benchmark can be completed with the AMD Radeon 7900 XT or 7900 XTX video cards. Keep that in mind. Even if the video card is featuring 12 gigabyte of video RAM on AMD Radeons, it still can run this. It depends if you're going to have enough GPU computing performance power or not. Okay. As you can see, Intel drivers sometimes lowering our frequency from 5300 MHz, which is 5.3 GHz, to 5200 MHz, which is 5.2 GHz at the left top corner. It decided by the Intel driver because it thinks that it's not necessary for us to use our maximum external frequency. And I cannot control that. I cannot just run external maximum frequencies. On the Intel 9000 series CPUs, it's a kind of scenarios. It's controlled by the Intel driver and by the BIOS of the motherboard. When it sees and decides if it's going to be beneficial to use the maximum external frequency, or if it's going to be beneficial just to use the AVX2 instructional frequencies, do that. AVX2 instructional frequencies will be using lower frequencies than maximum external frequency, and is going to utilize less voltage and deliver less wattage, generate less heat, consume less energy, but you're not going to receive the advantage if you're going to use the maximum external frequency. And it's decided by the Intel driver under the Intel 9000 series CPUs. So pretty much we don't need to have faster CPU look like Intel decided under this particular 16K video resolution benchmark tests. So there is a possibility that 13900K Intel CPU is not going to deliver even 10% performance in terms of the FPS. But hopefully I'm going to test it in the future with the Intel 13900K CPU that I purchased that CPU. And under the 4K video resolution, it delivers at least 10% higher performance with the same video card. But under the 4K video resolution, as again, the higher resolution that we're rendering in real time in our PC games using the commercial or open source API, the lower CPU utilization is used, and most likely the higher frequency will give you an advantage, but not going to give you as much as advantage as you can dream on. But the threads not going to give you additional threads, not going to give you advantage at all on a CPU. Hopefully, guys, I explained it well to you throughout this benchmark. A lot of information was available to you, so you're going to build much better computers. As again, don't forget to smash that like button, share it with your friends. Okay, let's get back to the benchmark. FPS 14.5, score 365, minimum FPS 7.5, maximum FPS 31.2. As a reminder, I used the DirectX 11 API. The quality was under lowest visual preset. It was using the tessellation under the extreme preset, which is maximum visual preset for the tessellation, and mode was 4 times anti-aliasing. As you can see, it's rendering 10,000 pixels on width by 8,631 pixel on height, which is kind of weird, but still I believe 16K video resolution in kind of weird aspect ratio, because the aspect ratio for the height will be 16K video resolution. Alright, so let's go ahead and now do the last benchmark. Actually, I'm gonna do 2 more just to provide all kind of data. I'm gonna switch now to the maximum visual preset, which is the ultra visual preset, but I'm gonna turn down the tessellation real quick to disable, but quality under ultra visual quality, 4 times anti-aliasing, DirectX 11 API. Let's do that, and then I'm gonna do for the last one with the tessellation at extreme. So pretty much every single data is provided to you, so you can analyze it like nobody else, okay? And use it the way you want it, but always keep my credits, guys. Please, credits to the UHD King YouTube channel, UHDking.com, but you can use this data. So maximum visuals without the anti-aliasing, and then I'm going to use the anti-aliasing, and I'm going to use some zoom. I'm going to show you the advantage of the 16K video resolution versus the 4K video resolution. I'm also going to explain it to you as a fact by the end of this video, and then I'm going to underline it, guys, for you why 16K video resolution is the maximum 3D rendering real-time resolution in the games in 2023 and older games as well. Through the commercial APIs or open source APIs, I'm going to show it to you as a fact for those naysayers, so they're not going to write it, all this nonsense. Every single piece of information will be provided to you. As again, don't forget to support this YouTube channel. A lot of time, money, energy is invested. Please watch my ads, so I'm going to collect those pennies, invest back into you through my games giveaways and buying better hardwares or more hardware. So we're going to share and we're going to test with a lot of hardwares and compare a lot of hardwares against each other. The grass is looking amazing, guys, under the ultra visual preset, under 16K video resolution. And just look at those visuals, it's just unbelievable. And the most important part, that every single pixel is rendered. So without the tessellation, the dragon will be kind of flat, as you can see. You're not gonna see any details on that dragon. But when I'm going to enable the tessellation, we're gonna increase, we're gonna divide those triangles, we're gonna define this 3D model of this dragon, as well as the landscape. As again, they're not applying the tessellation to every single 3D mesh, to every single 3D model throughout this 3D benchmark, but to a lot of 3D meshes like a landscape, terrain, and dragon, and some of the cylindric objects, they do apply the tessellation, and you can see it. And when you're gonna apply the texture on it, it's going to define the model much better than with the lower amount of polygons. So tessellation pretty much is increasing amount of the polygons of the triangles on that 3D mesh. So you don't have to do the low polygon 3D mesh, load it into this benchmark, and then do the high polygon 3D mesh. You can do just low polygon 3D mesh, load in this benchmark, and using the pre-built Microsoft classes under DirectX API or newer DirectX API, and just with a single 3D mesh you can have the advantage, like just the same way like it was like multiple 3D meshes. And this beneficial especially for the game developers, so they don't have to do like low polygon 3D mesh, medium polygon 3D mesh, high polygon 3D mesh. They can just supply a low polygon 3D mesh, and in terms of the storage of the game, they're gonna take advantage and benefits of that. So the game, instead of 130 gigabytes, it can be 30 gigabytes, and you're just going to increase the polygons count on those 3D meshes through the tessellation feature. Hopefully, guys, I explained everything what you need to know. As a game developer or as a gamer, you understand that, because the language that I explained to you, not like one of those copycats on YouTube that's writing bunch of numbers at the left up corner, using bunch of terms, and they do not even understand what those terms are. They cannot explain in plain English. Over the UHD King, no matter who you are, everything will be explained to you guys. Go ahead and check out my 3D tutorials, how to model, how to texture, how to animate, my graphics design tutorials as well, my software development tutorials, my game development tutorials over the UHD King. It's going to be a great, guys. By the way, I started my UHD King YouTube channel back in 2007 when I developed the world's first one of the world's first screen video capture. During that time it was only Fraps screen capture and Camtasia screen capture, and I developed Morose video capture that was capturing the screen capture in the games all the way to 4K video resolution back in 2007. That's why I opened my YouTube channel. So I have a lot of information to share with you as a software developer as well, as you can see, and great approaches I'm using. and explaining to you with the plain English, because I do understand everything what I'm talking about, guys. Not just because I like to talk, oh, you just like to talk, like those naysayers. No, just because I like to share a lot of information. I like to provide value to the community. Okay, guys, let's go ahead and get back to the benchmark. Average FPS 4.6, score 115, minimum FPS 3.1, maximum FPS 8.6. As a reminder, DirectX 11 API, ultra visual preset, tessellation was off. 4 times anti-aliasing. Alright? So let's go ahead and wrap up with the last benchmark. Where's the mouse cursor? As again, please watch this video on 8K UHD or 4320p. Switch it to your YouTube player for the best possible visual experience. Do that, I'm recording in native 8K through the modified NVIDIA Shadow Play and modified NVIDIA drivers. This is how it's possible, running on a single 8K screen through the DSR 16K video resolution. But it's already possible, guys, to run this with 4 screens, which is 8K 60 Hz, but it will be supported only on the RTX 4000 series video cards, because the Titan RTX video card during GPU architecture is only supporting 4 8K screens at 30 Hz. So tessellation extreme quality ultra DirectX 11 API 4 times anti-aliasing. The last benchmark, we're jumping into it with the maximum possible overclock system from 2018 that is performing almost as system from 2021, but system from 2022 will show around 10% higher FPS. Throughout base is going to have, if you're going to use the same video card, of course, do that, CPU going to perform at least 10% higher performance instruction per clock, even with the same frequency. Okay, I started the benchmark. For the last time, we're gonna keep our eye at the left top corner. Very stressful. As you can see, we are almost utilizing 23,000 megabytes of our video RAM. The system RAM utilization is still below 10,000 megabytes. That means that we are healthy video RAM utilization. We are not offloading any data from a video RAM into the system RAM, and when this type of process is happening, we are slowing down in terms of the FPS at least by 30% versus the healthy video RAM utilization, and we are increasing at least by 30% on healthy latency delay in terms of the milliseconds versus the healthy video RAM utilization. This is what I learned throughout my benchmarks under the 8K video resolution and above over the UHDking.com. So still 24 GB of video RAM will be more than enough for 16K video resolution in Unigine Heaven Benchmark version 4.0. I'm also, guys, going to test in Unigine Valley and Unigine superposition benchmarks. I'm not sure if superposition will be possible on a single Titan RTX or 2 Titan RTXs in 16K video resolution. Do that, it's using the ray tracing capabilities, while the Unigine Heaven Benchmark 4.0 doesn't use any ray tracing capabilities. It's just simple rendering, rasterization without any ray tracing capabilities. But Unigine Valley benchmark is nice to see if I will be capable to run that in 16K video resolution. Do that. That benchmark was released in 2013, while the superposition Unigine benchmark was released in 2017, while Unigine Heaven benchmark was released in 2009. So pretty much, guys, I would say you can run any games on 2 Titan RTXs in a SLI that doesn't utilize any RTX or any ray tracing capabilities in 2019, or all the games with 2 Titan RTXs in SLI in 60 FPS or above. This is what I learned throughout all my benchmarks, and I demonstrated to you as a fact, and it's available in all of those games over the UHDking.com. Go ahead and visit 15,360 times 8,640.com. That's going to be dedicated to the 16K video resolution, or visit iplay16k.com, that's going to be dedicated to 16K video resolution gameplays and gaming. So much information was provided to you guys. Hopefully you enjoyed that. I'm about to pick up a pizza. I ordered a pizza. I gotta go because I just ordered it through my phone like 10 minutes ago. So I gotta go ahead and pick it up. It's probably ready, and we'll almost wrap up with this video. As again, it's going to be below 2 hours, but a lot of time, money, energy is invested. Support me, guys, for more great, unique videos. As you can see, there is no copycats allowed here. They are all copying each other, but over here, unique videos, a lot of information. You're watching a future, at least 2025, but I would say at least 5 years in advance. This is at least 2027, when 16K UHD will be publicly available to broad gamers in 2027. But you in 2023 you are already capable since 2022 to build up 16K video resolution at 60 Hz with the 4 8K screens at 60 Hz that is supported under any RTX 4000 series video cards. But to be able to play in high frame rates, high FPS, you need to have at least RTX 4090 video card, or I would say go ahead and grab yourself at least TU102 flagship video cards such as Titan Ada if it will be released, or RTX 4090 Ti video card. But I would say if you're looking to play 16K video resolution and not just benchmark it, then I would say you need to have at least RTX 5090 video card, guys, or 5090 Ti. As again, without the RTX technologies or any ray tracing technology, because those technologies taxing a lot while delivering almost the same result as renderable result as restoration on a screen. Anyways, let's back to the benchmark results. Average FPS 4.3, score 108, minimum FPS 2.8, maximum FPS 7.9. As a reminder, DirectX 11 API, Visual Preset Ultra, Tessellation at Extreme, and anti-aliasing 4 times. Alright guys, that's pretty much it. The 8 times anti-aliasing is crashing even at lowest possible preset. I believe it's due to the video RAM overload, and it just overloading the video RAM with the data that cannot be stored on the system RAM, and that's why it's impossible on a 24 gigabyte of video RAM. I still believe, or maybe it's not even renderable in real time, but maybe renderable in real time like 1-2 FPS on the Turing GPU architecture, but lack of the video RAM to store the data that is going to be computed by the GPU. This is my assumption. Anyways, analysis. Guys, just because this is the world's first Unigine Heaven Benchmark 4.0 in 16K video resolution in January 2023, I decided to go ahead and give you some giveaway. You can download the game, which is the Oil Rush, based on Unigine game engine, and play it for free on Steam. Highly recommend. Real-time strategy. Go ahead and check it out. I'm going to record that Oil Rush in 16K video resolution. You can run the widescreen. It's using a little bit updated the Unigine game engine. I'm going to demonstrate the final level of that game over the UHDking.com in 16K video resolution. So there is nothing I can give you away based on this Unigine benchmark, but just because you like to watch benchmarks and most likely you like to benchmark your systems, I decided to go ahead and give you away the ADA64 Engineer Edition pre-purchase license key. Go ahead and visit their official website, download the trial, activate with this license key. the trial into the full version and register this key over their website. So you're going to be the only one that's going to use it. This is a single license for a single user. Okay, you can use it on your computer. It's a great software. I'm about to demonstrate you this software while I'm going to underline you as a fact. While the 16K video resolution is maximum video resolution in 2023 that can be rendered in real time under any open source or commercial API. But go ahead and use that, guys. This is the key. Engineer Edition is much better than ADA 64 Extreme Edition because it can support over 128 CPU cores, while the ADA 64 Extreme Edition can only support 128 CPU cores and 256 threads, while this one can support 1024 CPU cores or 2048 threads. Okay, this is as again, don't forget to smash that like button. Support me, guys. I need your support. And as you can see, I'm providing a lot of value no matter what kind of angle you're gonna look at it, no matter what kind of industry you're in. By the way, that Engineer Edition is great ADA. Highly recommend for you. It can tell you everything about your software and hardware on your system, installed on your system, everything about your system. Anyways, ADA 64 Extreme, let me open up. I'm going to use the Engineer Edition myself. It's going to be a Business Edition. Business Edition is even better than Engineer Edition, keep that in mind. But let me zoom in. Let me demonstrate for you why the 16K video resolution is maximum supported resolution, and it's pulling those values pulled right now from the variables of those APIs by this software, which is ADA 64 Extreme or Engineer or Business, no matter what version you're using. As you can see under DirectX 11.1, which is powered by the Windows 10 Professional Operating System, DirectX 12 powered by the Windows 11 operating system, 16K video resolution is the maximum, okay, that you can run as the desktop resolution. Under the Windows 10 Professional will be the same scenario under the Windows 12. Under the Windows 11, which will be using DirectX 12 API, which is fully supported by the Turing GPU architecture as well as hardware support. Vulkan API, same thing, guys. 16K video resolution XYZ as a maximum 3D image size renderable, which is open source API, and the texture could be 32K resolution, but only the texture. Okay. OpenGL. Open source API, 16K video resolution is maximum 3D texture, XYZ, or 32K resolution can be as a 2D texture. So pretty much 16K video resolution is the maximum renderable resolution as 3D surface, 3D world. No matter what kind of API you're using, sometimes they call 3D world, 3D surface, 3D canvas. It depends to the 3D rendering real-time API that you're using, commercial or open sourced. Let me real quick, this is my desktop. As you can see, it's registered as 15,360 by 8,640. Doesn't recognize my let me see, 32-bit. Yep, recognize everything correctly. This is how Windows see it. GPU, this is the GPU, guys. Some information about the GPU. As you can see, Titan RTX is overclocked. Everything what I told you is right here. 72 streaming multiprocessor, as we discussed. Level 2 cache 6 megabytes, level 1 cache 96 kilobytes, but this again is going to be 64 kilobytes and 36 kilobytes as addition, and 34 kilobytes as additional for additional data, but total 96 kilobytes of level 1 cache. While 64 kilobytes as usually used per streaming multiprocessor unit, while the ADA GPU architecture is 128 kilobytes. Okay, of course SLI is disabled because single Titan RTX is installed, but I have two Titan RTXs in SLI, will be used in the next benchmarks, and Unigine Heaven Benchmark supports SLI, but only single video card was installed to avoid any hot air pockets. What else? What else? What else? Let me see. I think, guys, I showed you everything what you need to know, right? It doesn't register the monitor correctly. As you can see, it doesn't pull the monitor correctly because I'm emulating right now. I modified the NVIDIA drivers. I'm not using the Samsung, what is that? It says Samsung 45 inches. No, my monitor is like, guys, about 60 inches, 8K Samsung. So pretty much, guys, everything what you need to know was demonstrated for you. 16K video resolution as a fact. Let me show you CUDA. Under CUDA, even under the CUDA, as you can see, 16K video resolution maximum, and this is NVIDIA API, and they know the best. But 32K resolution can be as 2D texture, data, layers, data, some array size, but 16K video resolution is maximum. 3D surface size, 3D surface under the CUDA, this is how they call 3D world when you render the whole deal, like the 3D models and animation called 3D surface, just like same thing under DirectX APIs. 16K XYZ, as you can see. Yeah, so everything was demonstrated for you guys. Hopefully you enjoyed that. Even the OpenGL, the same deal. 16K video resolution XYZ, and 2D to 32K can be, but as again, as only as 2D. As again, my name is UHD King, aka I play 4K, aka I play 8K, aka I play 16K. Have a good morning, good day, good evening. Don't forget to smash that like button, share it with your friends, subscribe for more great videos, visit my sponsor. So I'm gonna collect those pennies, invest back into you. So we're gonna do more computer science. Don't forget to check out video comments to the related videos, or right now I'm putting some great videos for you to check out. It's going to be a great videos for you to check out if you're into this topic. Have a great day till the next time.